In this video, we're going to take a look at scatterplots and what they can show us. Scatterplots are a graph where we plot points on the x and y coordinates in order to see a relationship between two sets of data. So in this example here, I have income per person and life expectancy. I'm comparing the income per person in any particular country, such as India or China or the United States, against the life expectancy of people in that country. And you can see it forms this interesting graph. This tool I'm using is called Gapminder. And what Gapminder is a tool that displays lots of different data in a colorful scatter plot that also changes over time. So I can slide time to see how this data has changed over time. And we'll get into some of those features later, but for now, let's just take a look at 2001. So one of the first things you'll notice is that there seems to be a pattern in this data. Now, it's not forming a straight line. It kind of goes up and then cuts over a little bit, but there is some clear association. So we're going to use the word association to describe the pattern. So anything with strong association has a clear pattern. However, it's easier to work with data and to do things like regression, which we'll cover later, if we can see a straight line. Now, whenever you see this shape where it kind of shoots up and then shoots over, or it shoots down and then kind of shoots over, kind of like this L shape, a lot of times what that means is you're looking at data that has one of the variables that is logarithmic. If you look at the scales right now, you'll see that the income scale goes from 10,000 to 20 to 30, 40, 50,000. It goes up by 10,000 each time. I'm going to change the scale to a log scale, and you can see the graph shift over. So these data points spread out differently now. So on this end, instead of going up by the same amount each time, here I'm going from 1,000 to 2,000 to 4,000. I'm doubling each time. So instead of adding the same amount, I multiply by the same amount. And then this would go to 8,000, which is pretty close to 10, double, double to 40, and so forth. So now we have something that's actually fairly linear, and we can do some analysis on that later. Next thing we want to look at today, though, is which variable causes the other one to change. So we have income per person and life expectancy. Does having more income improve healthcare such that people can live longer, or does having a longer life cause people to have more income per person each year? Well, if you think through the problem a little bit, you can have some conclusions, but the graph itself, the data on this graph, will not help you determine causation. All it will help you see is that there's a pattern. So the causation is completely all about thinking through the problem. In the case of having more money to pay for healthcare so that people will live longer, that's a pretty logical explanation. So I would say that income explains life expectancy. Now, living longer, you could argue that perhaps it means that you're in your job longer, and so therefore you will have more experience and you will make more money each year. But it also means that if people are living longer, they're probably going to retire and not produce income, but still count against the population. So I would say that the most logical one would be to say that income explains life expectancy. And so we call this an explanatory variable. It's the variable that causes the other variable to change. Let's take a look at a new example now. We're going to look at the temperature, and that's here in degrees Fahrenheit, versus the number of people at a beach. Well, your first instinct would say, okay, well, they seem like they would be correlated. As the temperature goes up, the number of people at the beach also probably goes up. However, the question is, which causes which? Does having lots of people go to the beach raise the temperature of the Earth? Well, I feel like in this case, that one's pretty clear. I don't think that it happens. However, as the temperature goes up, more people are going to want to come out to the beach. So whenever you identify your explanatory variable, you're going to want to put that on your horizontal axis, your x-axis. So down here, we're going to have temperature, which leaves the beach attendance over here on the y-axis. We call this the explanatory variable, and beach attendance is going to be your response variable. And for a quick definition, the response variable is the variable that changes with the explanatory variable. It's the follower, whereas the explanatory variable would be the leader. So going back to this, we need to make our own scatter plot. So first we want to go ahead and set our axes. Now I divided these up already. On the temperature side, since it starts all the way up at 60, I put my break in my graph and I started labeling at 60, 70, 80, 90. And on the beach attendance, it gets pretty close to 0, goes all the way up to 120, so I labeled from 0 to 120. And then when it comes to plotting your points, you don't need to be super exact if you're doing this by hand. If you're doing it on a computer, it'll do it exact for you. But just roughly sketch them in. So at 60 degrees, 22, pretty close, and so forth. You can plot all your points. And as you do this, you'll see, oh, that actually, it isn't a perfectly straight line, but that's a pretty strong pattern. Whenever you have something that has a strong association and it's linear, we're going to call that a high correlation, because correlation is referring to the linear association, how linear something is in a relationship is your correlation. And we'll deal with the actual values with that later. Final example, we're not going to go ahead and create a graph or look at the actual numbers. We're just going to talk about causation. We have the cost of a home and the cost of a car. How are these two variables related? Well, I would argue that when the cost of a home is high, when someone spends a lot of money on their home, they probably tend to have a nicer car. And vice versa, when they have a nicer car, they probably tend to have a nicer home. But which one causes which? This is one of those situations where neither of them really causes the other. In fact, there is a third variable, income, that probably can explain both. And whenever you have something behind the scenes that's not in the original thing you're talking about, such as income here, we call that a lurking variable. Definition of a lurking variable is a variable that is not displayed, but causes both the displayed variables, or explains both of the displayed variables. Here you can see income explains the cost of a home and the cost of a car, even though they don't necessarily explain each other. So you have to be careful when you're looking at two things that are correlated or have a strong association. It doesn't mean that one causes the other. Sometimes there is a lurking variable behind that causes both of them.